In this video, I discuss data-based decision-making. This term refers to the manner in which students' progress is used to evaluate an instructional program, with an emphasis on progress monitoring decisions, not screening decisions. The critical decision is whether the progress is sufficient and therefore the program should be continued, or whether the progress is less than expected and should be changed. Remember that instructional change can include adding or subtracting the amount of time being spent on a skill, the grouping of students, the tier of instruction, which often reflects time and grouping changes, the curriculum being used, or specific instructional practices. The three critical indices of the time series, or progress graphs, that are typically used to make decisions include the general level of performance, or its immediate change from the last value of one instructional program to the first value of a new instructional program, how much improvement is being made over time, the slope, and how much variation is present from one data value to another. On occasion, all three indices are so noticeable and consistent that debate or consternation is not an issue. However, more often, these three indices interact differentially, making the decision to keep or change a program quite difficult to make. For example, a student may show an immediate change in level for a new program, perhaps reflecting a novelty effect, and then show a moderate slope but with considerable variability. In this series of presentations, we will focus on 6 different examples of database decision-making and emphasize 3 indices. The first is the change in level. As you remember, that's the overall level of performance, and in particular the change after an intervention line from just before it, in this case the vertical line, that's September 30th. Change in slope, which is the overall trend over time, and in this example shows data points that move upward, hugging the 50th percentile rank. This is a grade level measure. And finally, variability, which you see in this case is variation around successive data points. And it appears to be more variation later in the program than earlier. So that's the first example, and other than the fact that there are very few data points on baseline to the left of the intervention, this decision appears to be an effective one because there's, though no change in level, there's great change in slope and not much change in variability. In the second example, the contrary is true, where you see only one data point, then within a month an intervention line on October 8th, no change in level, a pretty flat slope, and really only an increase in variability near the end on March and April. Otherwise, a flat slope would indicate this program really should have been changed after 4 or 5 data points, certainly by January. In this third example, you see 4 different intervention lines, and most of them don't show much of a change in level. However, the second to the last one does, and that shows the most extreme change in slope overall, and variability is really quite minor because most of that variation is upward movement with slope. In the last intervention line, the slope is a little more modest, but there's less variation and very little change in level. So pretty good decision making for this example 3. Example 4 shows you a long extended baseline with very few measures, and in particular no growth. So an intervention may have been warranted earlier in the program, although it would require more progress monitoring to be sure that that was true. Once the intervention has taken place, there might be no change in level, but a great change in the absolute value on the second data point, and then it flattens out. So basically the intervention doesn't appear very effective in slope or variability. In example 5, again, a similar long period with no change in performance before the intervention line. In fact, September through January is a long period for only 2 data points. This would be an example where a teacher could have progress monitored more frequently. Following the intervention line, you see a small change in level, a modest increase in slope, and not very much difference in variability. So had this intervention been given earlier, that would have been a good thing. And finally, you see a series of interventions, 3 of them in example 6. For the most part, there's not much change in the level from one of the last values before an intervention and the first value after. You do see an overall trend or slope upward and not a lot of variation. I would argue that the third intervention appears to be the most effective, and the prior ones, the prior 2 of them, not so effective. So that is a summary of some examples of decision making, some more effective than others. And what we've used is level, slope, and variability to evaluate the effects of those interventions using progress monitoring measures. For a variety of excellent training slides, visit the Center on Response to Intervention. As you can see, using student performance data to guide your instructional decision making may not always be simple, but it is important to take the time to understand the student's level of performance, change over time, and variation from one data value to another. These 3 indices interact with one another and relate to the instruction being provided, and they can help clarify the decision-making process.